Hello and welcome to this brand new wonderful video about GraphQL and Vertx. So likewise with the Hibernate Reactive, it also would be a series of several videos because I believe this is not possible to just put a lot of content, a lot of stuff just in one single video, or at least it's not the way it should be. So what we're going to do, we will create several videos. So I will create several videos, I think at least 3 videos about this topic. And in this video we will start with GraphQL, and we will talk what is GraphQL, and also we'll talk how we could access GraphQL endpoints, actually a single GraphQL endpoint using the Java code and especially Vertx web client, because this is like the first step we need to achieve, because when later on we will write an API test, we will need to understand how we actually could test our endpoint. So, if you're not familiar with GraphQL, you could go to the graphql.org website, or you could continue watching this video. And in this video, we'll talk about what it is a GraphQL. So, it is basically a query language for your API. This is a technology that we use in order to implement endpoints. So, likewise with REST API, we did previously. In this way, we also could use GraphQL in order to implement our API endpoints. So there are several advantages over REST, so it's not something that you should use one over another. It's always good practice to evaluate your use case, but there are several things that GraphQL could offer to you. And in this video, we'll start with learning how we could access GraphQL with Vertx. So let's start talking about what is GraphQL really is. Okay, let's start from the beginning and let's talk about what is GraphQL. Well, GraphQL is a data query API standard that was invented and developed by Facebook. So what does it mean to be a data query API standard? Well, technically speaking, GraphQL is not a networking protocol. In other words, GraphQL works over HTTP networking protocol, the same way we do with the REST specification. So GraphQL is basically a specification in a way we design our endpoints. If you're familiar with REST API design specification, usually we use resources. For example, we could have resources for users, posts, invoices, operations, etc. And then each of these resources will have endpoints for create, retrieve, update, and delete functionality. So we have a lot of different endpoints. With the GraphQL, things are different because we will have a single endpoint for all requests, where we usually send a post request. We usually send a post request, and as a body, we send a JSON object that contains a GraphQL query. So in other words, the purpose of GraphQL is to optimize API calls and to provide a flexible and efficient approach compared to REST. So is it really flexible? Is it really efficient compared to REST? Well, there are different use cases, and as always with technologies, you need to evaluate your use cases and you need to select technologies that better suit to your needs, to the needs of concrete projects that you work on. Next, let's review what are advantages and disadvantages of using GraphQL technology. Okay, so why to use GraphQL? Why we use GraphQL over REST API design specification? Well, the first thing first is that we will have a precise control over data fetching. In other words, GraphQL allows us to fetch only those fields from data models that we actually need. And in some cases, it will provide you with more flexibility, with more security, with more speed over using REST API specification. Of course, it will give you a more simpler data aggregation from multiple sources, because usually when we talk about REST API, we follow the idea of resources. In other words, when we have different resources, we need to retrieve several endpoints when we want to do a data aggregation. With GraphQL, we usually have one endpoint and we could do a data aggregation inside our server code. Well, I put here a comment because really it depends on your design skills when you do REST API specified server, and it could be an advantage of GraphQL or not, depends on if you do like relations between your data models, and maybe you don't need to do a data aggregation in this case, but actually it's like a common point to use GraphQL is this simpler data aggregation from multiple sources. And finally, of course, we will have less dependency on data layer models, which is also connected with the second point. So because we don't have resources, because we don't have predefined data models like we have in REST API, we could be very flexible on what we return as the response to clients, and we don't need to make our clients know about our data models. Well, it could be advantage, it could be disadvantage, depends on your skills, depends on skills of your team, and depends on necessities of your project. But usually, of course, this flexibility that is brought with GraphQL is a huge advantage over using REST API. Okay, now let's talk about why not to use GraphQL. So let's talk about problems that arise with GraphQL. Well, the first thing first, GraphQL will increase your query complexity dramatically because you will have your own query language, you will have your own models, and models are altered each and every query, so you have less predictability, and especially for front-end developers this could be a problem. The second problem that also exists for front-end developers is caching implementation, because usually caching libraries for client-side caching are oriented to work with REST resources rather than GraphQL. So you will have to introduce your own solution, and this will lead to more bugs and to more problems, and usually to a slower performance. And talking about performance, performance of the GraphQL server is usually slower than with REST API, and there are different benchmarks that advocate for and advocate against using GraphQL over REST, but in general, of course, performance would be much slower because GraphQL is much more complex query solutions than REST, and in this way you need to be ready to lower performance of your server. And as always, it is your duty as a software architect to evaluate pros and cons of using specific technology and its suitability for your project. Okay, without further ado, let's start and let's create a new project that we will use throughout this series. So, like I always like to do in my videos, I would use a Vertx app generator in order to generate a project, and you could use just a Maven with several other dependencies, or you could use SDK man. It's up to you. I will use a app generator. So if you follow me, go to the Vertx.io and going to start and select app generator. So this is a web application that allows us to quickly build a new Vertex application skeleton in a quite easy and visual manner. So we will use the latest and the greatest version of Vertex on this moment. We will use Java, we will use a Maven as a build tool, and we could now start by specifying group ID and an artifact ID would be a GraphQL demo. So let's select dependencies that we need. We need, first of all, of course, to use a Vertex web. We need to use a Vertex web client because we would like to access GraphQL endpoints. We also need to use this GraphQL handler, which is, if you will pay your attention, also includes this GraphQL Java library, which is a very handy dependency. So this is actually all what we need from this panel. And also, if we go to the testing tab, we will select Vertex JUnit 5 starter. It's also very important. And for this series, this is all. What about data access? We will not use any external database here. We will use just Java collection in order to keep the data. If you're curious about how to use PostgreSQL, how to use MongoDB as your data layer in Vertex applications, so I highly suggest you to check my book Principles of Vertex 2nd edition. If you would like to use an ORM such as a Hibernate Reactive, there is a free series about Hibernate Reactive and Vertex on my channel. Don't forget to check it out, but we will not use any data access dependencies here. So these 4 dependencies is all what we need. And let's just specify advanced options. So let me specify a package name, and I will use the latest GTK to 17. So let's generate a project. And as you see, we have a GraphQL demo.zip generated for us. And let me go to the conveniently created folder, which is called GraphQL demo, where I will copy all this stuff. And let me now select my ID and let's open this project. So it is in the devs, GraphQL demo, so this project. And let's import it to my ID. So this is basically all what we need from the Java side, but we also, as we will create client tests in this particular episode, we will need also to set up a mock GraphQL server. So let's see how we could do it. Okay, in this episode, we will write some code that will execute requests to the GraphQL endpoint. And because we don't have any GraphQL server yet, what we will do, we will use a fake server. So we will use an npm package that is called JSON GraphQL server. And if you're familiar with front-end development, chances are high that you know the package is called JSON server. So idea here is basically the same. What we will need, we need to install this package using npm, and then we need to prepare data in the form of JSON file, and it will generate a schema with queries and mutations that we could use in our testing. So let me go to the terminal and let me install this package. So npm install globally, and we specify a package name which is GraphQL server, or if you already have it and you forgot about it, you could use this list command to verify that. So in my case, I have installed the version 2.3.2, which is latest on this moment. And as we have this package installed, let's generate some data. So let's go to the website that is called mocaro.com, and it's up to you which fake data generator you use. I will use just this one. And let me create a list of users. So we will have here ID, we will have first name, last name, and email. And let me have 50 rows is enough. So let's push the preview button, and now we will select this data. We will select these 50 items, and we will copy them. And now we will go back to the idea, and let's create a new file inside the root folder, and we'll call it data.json. And here we will create a new JSON object. We'll call it users, and we will paste this data here. So now we will have this fake data that we could use. And let me go back to my terminal, and now we will call this package by using JSON GraphQL server command. We'll specify a name of the file, which is a data.json, and we also would like to specify a port, which let's say will be 5000. And now you see that the GraphQL server is running on the localhost port 5000. Let's start writing tests. Okay, so now we have a server, and let's execute requests to this server. And we will start with queries, and we will continue with mutations. And in a second, I will also bring you a difference between queries and mutations. But now let's start with queries. So let's go to the test package, and let me create a new test file. So let's call it client test. And as always we do with the Vertx test, let's extend it with Vertx extension. And the thing that I would like to do next is to set up a new class variable, and it will be a type of web client. I call it client. So if you're not familiar with Vertx web client library, basically this is a component that allows us to execute HTTP and HTTP2 requests. So unlike other frameworks such as Django, such as Spring, etc., Vertx has only one web client that is used both for real requests, and it will also use for testing. So there is no web test client, let's say, in Spring. So this is the only component that we use in order to execute HTTP requests. So let's set up it by using setup method. And don't forget to provide a Vertx and Vertx test context arguments here. And as we used it before each, that means that the new client instance would be initialized for each test method separately, unlike we used before all. In the later case, we need also to make this variable static. So let's initialize this by using create static factory method. And don't forget to finish this setup method by calling complete now. So let's start with executing some queries. The first thing first, let's create a new method called query test. And let's specify arguments. So what do we have here? We have here a list of data. Yeah, so we have here data of users, we have IDs, we have first name, last name, and email, etc., etc. And what do we need to do? The first thing first is always to retrieve by ID. How we could do it in the GraphQL world? Well, very simple. Let's prepare a new query. And here, what we'll specify, we first put it in curly braces. And then we specify a type, in our case it is user. And then we specify IDs that we would like to access. For example, here I'd like to get ID of, let's say 15. So ID of 15. And then you see another pair of curly braces. I put spaces here so you could see it normally. So let's specify fields that we would like to access. So this is like an advantage of the GraphQL. We could specify fields that we want. Let's say I'd like to have only first name and last name. I don't want to have an email and I don't want to have an ID. And then we specify this context verify block like we always are doing. And here we say client post apps, because we execute a post request using an absolute URI. We specify an address, localhost 5000, and don't forget to specify GraphQL endpoint. So if we will go to the terminal, you see that we have here a localhost 5000. And this is an endpoint where we will execute a request. And then we specify a send JSON object. So we will send data as a JSON, but we don't have any JSON object, we have only query. So what we will do, we'll create a new JSON object, call it body. And this JSON object will have only one key, which is called query. And we'll put it query here. So we'll send this JSON data. And now, because this is a future, we could specify on failure handler, because fail now, and on success we will have a response. So this response allows us to get a response body, which would be of type of JSON object, or we could only use a string, for example, in order to print data. Let's use a JSON object, and we call here response body as JSON object. And now we will just print it to the console. So no serialization here, just check what we have. And we'll say context complete now. So let me print this data by executing this query. And now you see we have here a data and we have here a type, user. We have first name and last name. So we don't have any ID on email, we just specify this data. And also here we have a JSON object, but you could also use just a string, as I said. If you don't do any serialization, basically it doesn't matter. I will say here body as string, so the same idea, but it will prevent some errors. So now we execute this request again, and now we have this data. Well, so this is the one request that we have. Let's create another request, which is called all users. So it allows us to have all data that we have. So we put a curly braces first, and then we say a name of the query, say all users. And we specify again inside the curly braces fields that we want to access. Say we have ID and first name. So this data we would like to access. Let's execute this query again. And as you see, we have a very long string because we have 50 IDs. So we will have this data entities which collect this all user list. Well, what if we don't want to have all these 50 items? We could do pagination. Likewise, after all users, we need to provide two parameters. The first one would be page. Let's say I would like to have a page of 2, and per page would be, let's say 10 entities per page. So let me run this test. And now, as you see, we have starting with the ID of 21, 22, 23. Why it is so, by the way? Why we have not from 11, but from 21? Well, because the first page, the first result page is actually 0. So getting from 1 to 10 would be 0 page, which we could verify now by using a 0 page. And now you could see we have entities from 1 to 10, and the page 1 will have items from 11. So this is way we execute queries. Quite simple way. We could also provide sorting, we could provide additional query parameters, but this is kind of like a basic stuff we do. So basically we execute this post request to the endpoint, but we also could do mutation. So let's check what is mutation and what is the difference between query and mutation. Okay, a quick note on difference between mutations and queries. So query is a type that is used in order to retrieve data, similar as we do GET requests when we write REST API. On the contrary, mutation is a type that is used in order to modify data, so to create, remove, or update entities. The same way we write post, put, and delete requests when we write REST API. So, JSON GraphQL server package allows us to use several automatically generated mutations once we provide the data. So, basically mutations that are supplied by JSON GraphQL server, they are listed inside the generated types and queries section of the documentation. And these are basically basic CRUD methods such as create many, update, and remove. So these are basic mutations, but of course when we will write our own custom servers with GraphQL and Vertx, we could provide more customized mutation, and this is kind of like a beauty of the GraphQL technology. But nevertheless, let's write a simple mutation test, and let's use create functionality as an example. Let me go back to the IDE and let's create another test. So we will call it mutation test. And don't forget, provide Vertx and Vertx test context. And the logic that we will apply here is the same. We create a query and we create a JSON body, and then we send it to the endpoint as a post request. So let's create a query first. Then let's create a JSON object. We call it body. We specify body, so we put here only a key, which is query. And then inside the context code block, what we will do, we will execute request, the post request. So we use post with the absolute URI. So in our case it will be HTTP localhost 5000, and then we send the JSON object. So we use here body. We provide on failure handler, and we provide on success handler. So we have a response, and all we'll do, we'll get us just the data. And we only print it out. So we don't do any assertions in this section because we just get the basic logic of request. So basically it's the same idea as we did previously with queries. The only thing which is different is the query itself. So how will look like a mutation query in GraphQL? Well, we start with a mutation keyword, and then inside curly braces, first we specify a name of mutation. In our case, it create a user. Then we specify parameters that we would like to save. And finally, another pair of curly braces where we specify a return ID. So this return value, which is ID. So once the data is inserted in database, it will have a new ID. So how we specify values here? Well, basically we provide key value pairs. So let's say we have first name, and we specify we need to use a slash symbol because we want to use escape characters. And let's say we want first name as John, last name would be Do, and we have an email, say johndoemail.com. And this is a kind of list of values that we would like to insert. Let's check in data.json that we have first name, last name, and email. And now we could execute this query. And the new ID is provided for us. So just to pay attention that here we have not a type like we did in queries when we had like a user or all users, but the same idea with all users, we have a name of the operation, the name of mutation, which is a create user. And if we will run the test with all users, you could see we also have a name of the query, which is a name of all users. So this is the way we could write simple API tests or API requests using just Vertx web client. And in the next section of this series, we will start implementing our own GraphQL servers using GraphQL server using Vertx and GraphQL Java libraries. So don't forget to subscribe to this channel so you will not miss the new episode of this series, and I will see you soon.